Old, right? Hi, everyone. Good evening. And what I want to do. Oh, yeah. So we have a presenter today. And you uploaded it, right? Yay. This is most, I guess. Yeah.
How should I do?
Yeah.
Did we start the presentations yet?
We have one person already.
Because I think I'm also scheduled to go today.
Okay, I wasn't looking. But it sounds good. It sounds great. Okay, upload your presentation here. Did you upload it?
Yes.
Yeah, okay. So go ahead. Okay, so we have two presentations. Oh, no, she's here first.
Oh, okay.
Otherwise, I have-
Does this record like your face?
What?
Does it record your face or no?
Oh, I'm sorry?
Does it record your face?
Oh, I think you could, what? You could turn off video. if you-
Sorry, but-
Let's see, I forgot how to do it. If you want to turn off your face,
Video, yeah.
you just,
Just click the
Just
video
click on the
icon.
a video.
Yeah.
Okay, but you can still see the screen, right, everyone? She is shy. Okay. Okay. Go ahead. I think so. Yeah. Yeah.
Press the
The down button?
no, not that.
I did.
On
Oh.
the left.
Oh.
Further to the left.
This?
No, if you wanna like
Press the folder.
add the folder would take you to it. It's a PDF of
Oh, it's a PDF?
Oh, boy. Oh, never mind. I think this is good. Is that okay?
Yeah.
Okay. So today I'm gonna be talking about some of the issues with SQL databases. As we know, SQL is very powerful and reliable because it allows us to work with like large amount of data and it keeps data very accurate and safe, but it also has its challenges. So I'm gonna be talking about 3 issues. The first one, this is just an overview. So the first one I'm gonna be talking about is like rigid schemas. So SQL has a very strict structure, which makes it like very hard to manage. The other one is scalability limits. And this means that as database grows, it becomes like very difficult to keep a strong performance. And the third one is performance bottlenecks, which is like if one part of the system slows down, then like it slows down everything else as well. Okay. So a bit deeper into rigid schemas. So a schema is like the blueprint of a database. And in SQL, like once you define the schema, it's fixed. And every row in the table has to follow the exact same structure. This works fine if the database is small, but when it grows, adding or changing fields can become a problem. And as the schema changes, it causes downtime problems, it requires data migration, and it also adds extra maintenance work. That's why they're considered rigid. The second one is scalability limits. So scalability is basically how well a database can handle growth. So with SQL, the most common way to scale is vertical scaling, which means like upgrading to a bigger, more powerful server. But the problem is servers get expensive and they also have their limits as well. And there's another type of scaling called horizontal scaling. And this is basically like horizontal scaling is it's spreading data across multiple servers, and this is possible, but it's very complex with SQL because database has to maintain consistency and relationship between tables, which makes the distributing of data harder. And last but not least, we have performance bottleneck. So as I mentioned before, like this means that if one part of the system slows down, everything else also slows down as well. So in SQL, queries get slower as database grows. And joins, we have like natural join, inner join, outer join. Joins, they're very resource heavy. And because they take up, it includes like lots of comparison and memory and processing. And if many users try to update or query a database at the same time, it can cause locks and delays. And complex queries with subqueries and aggregates take longer, which makes it worse for us in general because it slows down as the system gets larger. And to wrap it up, there's 3 main issues with SQL databases: rigid schemas, scalability limits, and performance bottlenecks. There's also many other more like data integrity problems and maintenance challenges. This doesn't mean that SQL isn't useful. In fact, it's one of the most reliable and most important tools for structured data, but it's also important to understand the challenges when using SQL in a large scale. Thank you.
I have one quick question. What would be the alternative? You don't have to, I'm just wondering if you know, what would be the alternative to a SQL database? Did you ever come across that? You don't have to.
I took it a semester ago. I low-key kind of forgot.
No, I don't think they did.
They taught that, yeah.
They probably just taught SQL, right?
Yeah,
Right. But they have now object-oriented databases.
yeah.
I can't remember one of them, but whatever, yeah, a MongoDB. That's
Oh.
very popular.
Oh.
It's pretty cool. Okay, thanks.
Okay.
Very good. Okay, so you're, you want to turn the camera, turn it on. Thank you. Very so much.
Okay, so I'm Soja. My topic was how do Six Sigma and Agile differ? So both of them kind of aim to enhance efficiency and deliver value, and they take distinctly different paths to reach these goals. Agile kind of works with short sprints with steps like plan, build, test, and review, while Six Sigma uses frameworks like DMAIC, which I'll talk about in a bit. Agile adapts to customer feedback, while Six Sigma actually defines customer requirements up front and ensures that they're met. In both, the end goal is delivering more value to the customer, and they both work to making their systems more efficient. So Six Sigma is a data-driven methodology that focuses on reducing defects and variability in processes. It was first developed by Motorola in 1980s. It uses statistical analysis to find and eliminate errors with the goal of achieving near perfect quality. In fact, the term Six Sigma comes from like the statistical measure where like 99.999 I think 96% of all opportunities are expected to be free of defects, so which is like 3.4 defects out of like millions of chances. Some of the key statistical and analytical tools they use is process capability analysis, which is like how they measure how well a process meets specifications. They use regression analysis to understand relationships and predict outcomes. They do a lot of design of experiments to test changes and see what works best. They do control charts to monitor processes over time, and they do a lot of hypothesis testing to validate improvements with data. So at the heart of Six Sigma is DMAIC, which is a framework. It stands for Define, Measure, Analyze, Improve, and Control. They define the projects to meet customer requirements. They measure the data to establish the current performance. They analyze the data to identify the root causes of the problem. They improve the process by developing and implementing solutions, and they control the process by monitoring it so the improvements last. There's also a related framework called DMADV, which follows the first same 3 steps, but it focuses on design and verify, which is usually used when creating brand new processes or products. So with Agile, it emerged in software development in the early 2000s, and it emphasizes flexibility, collaboration, and rapid iteration. Instead of delivering a huge project all at once, Agile works to break it down in small, manageable chunks called sprints, and it allows the teams to adapt quickly to changes and deliver value incrementally rather than waiting until the very end. The approach is also guided by the Agile Manifesto, which kind of highlights 4 important values. One, prioritizing individuals and interactions over processes and tools. 2, delivering working software over comprehensive documentation. 3, encouraging customer collaboration and contract negotiation. And 4, responding to change over a rigid plan. Overall, it really values adaptability, teamwork, and customer focus, and making it a really powerful framework for modern product management. So Agile uses a framework called Scrum, and it's built around like a cross-functional team working together to deliver a product. Work is usually organized and prioritized in product backlog, and the team tackles it in short time box sprints, which is usually like 2 to 4 weeks. And each day there's usually like a short scrum, like a short meeting to align and remove blockers. And at the end of every sprint, so at the end of every 2 to 4 weeks, the team kind of holds a review to check progress and see what they have to identify to improve. This iterative cycle kind of helps the team focus and keeps deliver manageable chunks of value and ensures that they stay aligned with project goals. So all in all, Agile is kind of keeping about teams being creative, innovative, and able to adapt quickly when things change. And on the other hand, Six Sigma kind of focuses on making sure processes are efficient, consistent, and high quality. But a lot of people in the workforce kind of combine the two to strike a balance, using Agile's creativity alongside Six Sigma's operational strength. They kind of fill in each other's gaps, helping businesses succeed on both the creative and operational sides. So you're still driving new ideas, but you're doing it in a way that's organized and reliable.
Anybody else or? Okay. Okay, thank you. Video case. Okay. Okay, so we left off. We were discussing okay, so for today, what I'd like to do is object-oriented principles, but so far we've done 6 of them. Do you remember all 6? You remember first 4, you should remember for a job interview? Anybody remember all 4? First 4? Right? The first 4 are what? Give me one. Inheritance, right? The idea is to reuse code, right, by inheriting from an object, right? That's the first one of the first. The other 3 are what? Which one? The polymorphism, which means what? Well, poly means many. Just
the casting, right? Polymorphism include casting?
It has to do with like operator, method overloading. That you could have, like you just have like one method, and it can have different parameters. So you don't have to remember, like you just remember the name of the method, not, and then the compiler automatically chooses the correct method to use, right? Because it's easier to understand. Before they had this, you used to have every single method had to have a unique name. So every time you change one little thing, you would have like, like add 2 numbers would be called add 2 maybe. And then if you had 3 numbers, it would be add 3. If you had 4 numbers, it would be add 4. So you always had to make a new name. So it got crazy after a while, right? So you would get these libraries and you're trying to figure out which method you should use because they all sound similar. And so starting with object-oriented with C++, then you could reuse the same name, just change the parameters. So that's like an easy example of polymorphism. Okay, and then what were the other 2? Say it? Abstraction, what does that mean?
It's like when you like hide complex
Right.
like interfaces from the user.
Right, so what's an example of abstraction in C++, in object-oriented programming?
Like hiding like advanced code or like advanced features from the user.
Or anything, anytime you have an object that has code, you're basically doing abstraction, right? Because you're hiding how to do something, right? Because if I do something, that means someone else. If I write an object that does something, then no one else has to know how to do that one thing I wrote, right? They don't have to look at it. Because I did it for them. And what's the last one?
Absolutely.
Yeah, what does that mean? Right, basically, right. So basically, we're saying that in other words, before C++ or before object-oriented programming, there was one person could just start changing code or change values or the way the code worked, and that would like just break everything. And there was nothing you could do to prevent it, right? But with objects, you could say, this is my class, I'm in charge of it. And in order to mess up my code, you have to actually go into my actual code. You can't just from outside the object to mess up the values. So like it sort of protects the code from other objects, right? So it works the way I think the person who wrote it, how they want it to work, not how someone else thinks it might also work. Someone says, oh, well, let me just set this value to this, and then I'll cause the code to zigzag instead of, but that's really dangerous because the person who wrote it never intended it to work that way. So basically it makes the code easier to understand and easier to test, right? Let's see, and what else? And those are the first 4. Those, everybody knows those, right? So you know that. And then the other two we did so far is open close principle, which is open for extension, closed for modification. Right? That means that, in other words, how could existing code break?
there's only one way existing code could break, and that is that if you change it, right? Otherwise, why would it break, right? So modification is the enemy of a good code, right? Because every time you change it, there's a chance you're gonna make something go bad, right? So if you extend the code rather than modify it, it's safer because then you don't have to worry that you broke existing code. You only have to just you only have to test the new code, not the previous code. So that's why it's safer, right? So that's a strategy pattern. That's an example of that. Observer pattern, another example. So those are all cases where we just add things. We don't change existing things, right? We keep on adding more objects that rather than changing stuff. So that's very important idea that people think, oh, you need to make a change. I'll just add an if statement. If this, do that. If that, do that. So, and then eventually the code ends up being, have lots of bugs in it. It's easier if you don't change the code, but rather just pass in the code that changes, right? That's the whole idea behind the strategy pattern, right? To put into an object the things that change. Okay. And then there's number 6 we did so far is we prefer what to inheritance. What's better than inheritance? If we could do it. Composition over inheritance, right? Inheritance, we said, is a little bit too strong, right? Why is it too strong? Because, does anybody remember what's wrong with inheritance? Why is it? What type of relationship? Well, I'm sorry? You're close, but what? It's the opposite of a has a. Is a relationship. So the child is the parent, and that's a little bit too strong because maybe the parent has only one thing we want, but when we do inheritance, we're getting everything. So the parent might do 1,000 things, and now we just wanted one little thing, and now through inheritance, we're getting everything, right? So it's too strong of a relationship. So composition is where you have the object. In fact, I think I have it from last week. Let me just see if I have an example. So of the 2 ways you could do it. It's a nice example because it's a simple example, but it shows us how to do why it's better. So let's see if I can find that code. Okay, so we had that and so we had here. So we said that there's a thing here. There we go. Okay, so for example, over here, we could have a dog which inherits from an animal, right? But the dog, everything inside the animal, the dog will get. So animal over here, example, barks loudly and eats. So now the dog gets all those methods, right? But since, I'm sorry, right, the dog, and if the dog doesn't want to do things the way the parent does it, the dog has to create their own method to fight the parent, right? So, or like, for example, the animal might do something a dog doesn't do altogether. So, but with composition, I get the same benefit of animal, but instead of inheriting from animal, I have an animal inside of me. So by the dog having the animal inside of it rather than being an animal, the advantage is that the dog has the ability to use the parts of animal that it wants to use without being forced to use it. You see why is this? I don't know why it's not. Oh, here we are. Okay, so if you look at over here, the dog that uses composition could use only the parts of animal that it feels like. It's not automatically getting everything from animal, right? So it could pick and choose. Either I could, since animal is part of it, right? Composition means that I have an animal inside of me. So the dog is able to use those parts of the animal that it feels like using. Okay? Are you able to see that? I'm sorry if it's too dark. Should I turn off the light maybe? That's easier to see. Okay, we're just reviewing so far. Of the, sorry, yeah, this, it's like a bit, that's a black background. So, anyhow, so, okay, so that's so far. So we're up to 6 object-oriented principles. Okay, now I want to do a few more. So these are called, we're going to do the ones that these are also pretty well known. And where is I don't went to my folder. Here we are. Okay, so here we are. So this is my list. So so far we've done the first 6. Okay, right? We did the encapsulation, abstraction, inheritance, polymorphism, prefer composition over inheritance, and open close principle, right? So next, we're going to do what's called solid. Solid is it stands for these principles over here that we're going to do. Okay, so the first one is actually not even, you don't even have to show it in code. It's just a logical idea, which is that code should be simple, right? It's called SRP, Single Responsibility Principle, okay? So the idea behind single responsibility principle is very simple, right? If code only does one thing, right, then then if I change it, I can only break one thing, right? So if and also it's much easier to understand the code, right? If I separate code, if I have a piece of code that does 2 separate things, it's very complicated. It's very easy to break one thing when I change the other thing. But if it's only doing one thing, it's simpler. It's also mathematically going to has less risk, right? Because the less things that a piece of code is doing, so the less risk there is when I change it, right? Right. So if somebody messes around with the light switch, the only thing they could break is maybe the light. But if they mess around with the electric box in the basement where all the current comes in, they could break everything in the house, right? They could lose all the power, they could short circuit everything, right? They could fry everything. So the more so the less something does, the safer it is to work with. Okay. So that's what I wrote over here. So when modifying code, the less a class or method does, the less chance something will break, right? So we're reducing the risk. And number 2, it's easier to understand. And also code is more reusable because it only does one thing, right? Because, right, so for example, let's do an example of non-reusable code, okay? We'll call this. Okay. Let's do an example of something that would not be reusable, would not be single responsibility. Does anybody want to like for example, let's say I have a math object, and let's say this math object, what it does is let's say if it'll, I'll do, let's say, int add, and say it takes, two numbers. And it adds them together. Okay, so this is a, simple little object, right? Oops. Okay, so this is a simple little method, right? I should make it public. And right, so this is going to add two numbers and return the addition. But but let's say my boss says, whenever we add two numbers, we want to also, let's say, send an email. So I'm going to add over here, I want to, so I'll do, so being that I'm a lazy person, so I'm going to, so again, the requirement is to, so the boss asks me to add two numbers and email the result. So, so I could do something like this. I could create so I think, well, I'm object oriented. I'll do a email. I have an email class, and I'll have a method called public void send email. And let's say I'll send int data or something. I don't know. So I'll just do something like sending or emailing, sorry. So far so good. So, and then I'm going to email the data. Okay, so then, okay, so far so good. So I have an email object and I have a math object. So they're both only doing one thing, right? But then my boss asks me to add two numbers, and then my boss asks me to email it. So I say, well, I'm already doing adding here, and I'm a little bit lazy. So what I'm going to do is, and I don't want to have to change the code too much. So I'll do int return is equal to this, and then I'm going to do, then I'm going to say email equals to new email, and then I'll send an email. I'll do email dot send email. I'll pass in the return, and then I'm going to return the over here. So I'm keeping the original code of adding the two numbers, but I'm adding in emailing. So now our code is a mess. Why? Because anytime someone says, oh, look at this beautiful math class, it adds two numbers together, what's going to happen? It's going to do an email also, right? So I just took simple code, which, two separate objects, and I put them to, and then when my boss asked me to send an email, so, and instead what I did was I put them together. They really don't belong together because they really have nothing to do with each other, right? One has to do with math, one has to do with email. But now, and every time somebody wants to email, wants to add two numbers, they have to, it's going to do an email also. Unless I put an if statement that says, I could add an if statement. I could say, I could see this happening, send email, and then you'll actually see this in companies. You'll see something like this. You'll say, if send email equals to true, then we send the email. So, yeah.
In that if statement conditional, You technically don't have to put the equals true because.
You're right, you're right, you're right.
You guys, if it's true or wrong, if it's not, then it won't.
You mean you could do it like that?
Yeah, because it'll save, that, like, little bit of.
Yeah, okay. Yeah, I mean, I just did just to be clear. Yeah, I know. Yeah. Some languages won't let you do it. I don't think C# will let you do it. Because in especially in C, this is dangerous because in C, everything it's just going to evaluate it. Well, it could be a pointer, right? It doesn't have to be a Boolean. Anything that's not 0 is going to be true in C. So,
What's the top? This will get John, you can simplify.
oh, okay, you're right. Okay, yeah, I wasn't sure. Yeah, I just did it for the. You're right. Okay, so but this code is a mess, right? Because even though it works, but now all of a sudden I have all this complexity that instead of just 2 lines or 1 line of code, I have 4 lines and now have to worry about that when I change the email, maybe it's going to break the adding or vice versa, right? Because now I'm doing 2 things instead of 1 thing, right? So this is a big mess, right? So you should never have code like that, right? You should have, if you have to, you would maybe make a new object called add an email or something like that. You do something like, maybe you would do like email or add an email, something like that. So there, you wouldn't be messing up the ad or the email, right? You would just put it somewhere else, right? So it won't be a big mess, right? You would do something like this, like you have a method called void add and email. It should be public, let's say. And then whatever it is, and then it would just do, it would do like math. And then it would do, and then you would, whatever you would do. But you wouldn't destroy the, the email or the math or the email class. You keep those the way they are. And now all I have to test would be this class, a new class, right? This would be an example where I would do, I would pass in, you'd say 1 number and 2 numbers, right? This would be a lot safer. And then I could just do math dot add, and then I would, it's with a small a, and then I would do int, I'm sorry, I1, I2, and then I would do new email that, no, what? New email. Oh, I forgot to do, sorry. New email. I create the object, then I would do send email, and then I would just math that. I'm just a little bit in a rush, so I made it a little bit quick. Be something like this. So it would be send email. Oh, I forgot to do new. Okay, so something like this would be the way to do it. Okay, so the way you would do it would be you would whatever. So I would fix up the math, and this is the way you would do it. Okay, it wants a false, let's see. Okay, so this would be the correct way to do it. Okay, so I'm just adding more code instead of modifying existing code, right? So I'm extending it. And also I'm keeping the math and the email just to do what they're good at. One is either sending email or adding numbers. And if I want to do both add and email in a object, so then I'll create a new object over here, which is going to just do the adding and the sending, right? It's going to use the other objects, but it won't change them. Okay, so that's the idea. And over here, I gave another example. If I have something called, oh yeah, same idea, add two numbers and print them. So same idea. It's a bad method to create because it's doing too many things, right? You want just to add or print. You don't want both in one method. Okay, so that's the SRP, single responsibility principle. Okay, that's what the first, that's the S in solid, right? Okay, the O we've already done. The O is open closed. So we already got SO. And okay, the next one is the Liskov substitution principle. Substat. I think I left out something. Yeah. So who is Liskov? So Liskov is actually a person, and she's still alive, I think. And Barbara Liskov, and that's her. And she came up with this principle, and this is her idea. She got a whole principle named after her. So, okay, so um, okay, so the idea is that well, first we'll say it, then we'll show it to you because it's easier to show than to explain. The idea is that if a parent object or class returns a certain result, then it's children of that. In other words, you shouldn't have children with the same method which act differently than the parent. In other words, it's either just to show an example. This is a famous example. It's probably if you ever, it's like if you Google it, you'll always come up with this one. So let's say, for example, you have, what am I thinking about? Yeah, so let's say you have a square, and I spelled that wrong, and in my square, I have I have a length and a width, right? So let's do a private int length. Oh, I'm sorry. I have a rectangle. Sorry, other way around. I have a rectangle and I have a length and a width. It's going to ask me to rename it. Whatever. So let's do a length and a width. Okay, so yeah, it's gonna make me rename it. Okay, so now if I want the area, oh, so now this is private, right? So how do I set it? Remember, what do we say? This is encapsulated, right? So no one outside rectangle could change the length of the width. So how do I make it, how could people change it? How do I make a private, how does this is encapsulated, right? Because it's private, so it's hidden from the outside, right? No one else could change length or width. So, except for rectangle, right? I'm the only guy who could change it. So how do we expose the length and the width to the public? Remember what we said? We do a getter and setter, right? So if I right click over here and I generate, I do a getter and setter for both of these. It just, in Java, it's a lot of code. It takes up, I always put this at the bottom because it's, it's like a lot of busy code. Okay, so basically we expose the private members through these public get length and set length and get width and set width. So I could control, for example, how my width is set. So for example, I could say that you can't set it to 0, right? So I could say if width equals to 0, or let's say less than or equal to 0, then I return. So I could control, I see this is example of encapsulation because I'm protecting my width, right? I'm saying that you can't set it to be less than or equal to 0. And I could do that also over here. When you try setting the length, I could say if length is good, if you're setting it less than 0, I'm going to return. Okay, I'm not going to allow that. Okay. Okay, so this is my, and then I just need one more method, which is going to be my area method. And this is just going to return the area of my rectangle, and it's going to return the width times length, right? Simple. Okay. Okay, so that is, this is my rectangle. This is really good. Okay. So then I think, wait a second, I also need an object called a square. So I think, wait a second, a rectangle, a square is really a form of a rectangle, right? Because if you think about it, right, what is a square? A square is a rectangle where all the sides are equal, right? So I say, you know what, I'm going to inherit, so a square is a specialized form of a rectangle, right? You could think of it that way, right? You could think of it the other way around, that a rectangle is a form of a square. But let's just keep it simple. And let's do right now I think a square is a specialized form of a rectangle. So I have my square. And I'm going to do my inheritance because it's a rectangle. But it's a special form. How's it special? Because the square, all the sides have to be equal. So no problem. So in my, over here, I'm going to override I'm just going to copy some of that code. I'm going to put it in here. And I'm going to, well, this is, why? So I'm going to, so what I'm going to do is, when every time I set the length or the width of a square, I'm going to call set length of the parent, right? So I'm going to pass in the length. And I'm going to, watch this, I'm going to do set width also with the length. So I'm going to make it so that both the length and the width are always going to be the same, right? And I'm going to do the same thing here with the width. So actually, I don't have to do that. I just have to do this. And voila, I have my square, right? Let me just fix this. And this. Do you see what I'm doing? So what I'm doing is, I know that a square, the sides are all equal. So whatever I set the length or the width, I set both everything to be the same size. Okay? So what's wrong with this code? It looks good, right? So the problem is well, to see what's wrong, let's do, okay, let's do what's called a unit test. So let's do a unit test of rectangle. So, okay, I don't know if you've ever done a unit test, but it's pretty cool. So a unit test is something that's supposed to test just one object. Okay, it's not a comprehensive test, but it's something that the programmer does just to test their own code. Okay, it's not written by other people, it's written by the program. So since we're programmers, let's write the code. So I go over here to rectangle, I open it up, and then I do right click it, and let's see if this works. And it should generate a test. So I'm going to have something called, I'm going to test the area method. Okay, so I just always have to click all this. And okay, so over here, so here I could write a test, and then I could call a method called assert, which is going to, in other words, the way it works is a unit test is, we're going to get more into this later on, but in fact, for your project after the midterm, you have to make 2 unit tests. So it pays to, to learn how to do it. So basically, the idea of a unit test is that it's able to run by itself, meaning that it doesn't need anybody to be there. And because it doesn't need any, in other words, the unit test could be able to be run automatically anytime someone wants to test the code. So they don't have to look at the result to find out if it's accurate or not. So the only way you could do that, if you think about it, is if it's true or false, right? How else could it run by itself, right? If you have 3 possible answers, how do you know, right, if it ran correctly? So the idea of a unit test is it should be able to run by itself. So there's a whole library built around this. So what we're going to do now is we're going to create a rectangle and new rectangle. And we're going to do rectangle that set length to be, let's say, 5, and rectangle set width is going to be, let's say, 6. And then we're going to test to see if the area method works. So we're going to do assert equals, and I forgot all the different options. I think one of them is assert equals, which is too many options. Let's do one of the, let's do one of these. This is, yeah, assert equals, oh, so this is what's expected and this is the actual. So let's try that. So back over here. So we're going to say the expected is going to be what? 30, right? 6 times 5 is 30. And the actual is going to be rectangle dot area method. Oh, oops. Dot area. And I missed my dot. Okay. Right, so if we run this now, so now you know this is pretty cool. This is, you notice on the side there's a green arrow. So now we could run this test and see if it works. So this test is going to verify that our rectangle works correctly and that the area is indeed 30 for this rectangle, which we expect it to be. So it's running, it's taking its time, and okay, so it passed. So remember I said it's either pass or fail. There's no in between. So for example, if I would have put 31, right, it would, now it should fail, right? So I'm not sure what that meant. I think it's a breakpoint. So if I run it again, right, you'll see that now it's going to give this check mark at the bottom is going to be red, or it's an X or something. I forgot. Yeah, so now it told me that yeah, it said expected 31 and it got 30, right? So that's an example of where a test would fail. But of course, it's really 30, so that's good, right? Okay, so far so good, right? Everything's working. Our unit test is working, everything is working, right? So the problem is that according to the Liska substitution principle, that if I use a child of a class, I should get the same result. So let's say, for example, I substitute instead of now remember, what does a rectangle, what inherits from a rectangle? A what? A square, right? So, so I could have, so a rectangle is a rectangle is this, I'm sorry, is a square a rectangle? Yes or no? A square is a rectangle, right? Because A is a relationship, right? So, because we go to square, you'll see that it inherits from rectangle. So a square is a rectangle, right? So therefore, we would expect that when we run this test, we should get the same result as when we do new rectangle. So first of all, let's go over this again. So first of all, a square is a rectangle. Therefore, we could have this rectangle pointing towards it, right? Because it is a rectangle, right? A square inherits from rectangle. So, but yet, what's going to happen when we call set width? It's going to, it's not going to call that one. It's going to call the other square. Where is it? Over here. It's going to call this one, and it's going to set both of them to be the same, right? So when we run this, what's going to happen? It's not going to be 30, it's going to be 36, right? Or it should be. So let's run it and see if that's true. So if I run it now. We're expecting 30, but it gave us 36, I think. What? Oh, it did a Stack Overflow. That wasn't good. Because, wait a second, set length called, why did it call Stack Overflow? Where's square? Because square is calling, oh, I see. I have to do super dot, no, it has to use the parents set line. Sorry about that. Okay, so, okay, so if we run the test again, now it should, it should run, but it should fail, okay? Okay, so over here it failed, why? Because it expected 30, but when we changed the object was pointing to, it gave us a different result. So that's what she's saying, is that we don't want that. We don't want code that works, let's say a rectangle, a reference to rectangle, and you get a certain result. We don't want the child to give a different result than his parent, right? So if the parent would give 30, then the child should give 30 also. Shouldn't be that the result is going to change based on, because the child changes how things work. Okay, so that's the Liska substitution principle, that if you substitute a child for its parent, you shouldn't get a different result. And over here, if we put square, we get one result. I'm sorry, rectangle, we get one result. And if we put square, we get another result, right? Right, so if we do rectangle, we get one result. And then when we substitute the child, which is square, we get a different result. So we don't like that. So this works, but this doesn't, okay? So, yeah, I'll just write that down. So in this example, um, rectangle doesn't, I'm sorry, square doesn't work. Square and rectangle give different results for same method. Okay, so that is so the area method is returning a different value between the parent and the child. Okay, so okay, so right, so square rectangle returns 30 and square returns 36. Okay, because it's getting the 6 for both, for everything when you call set width, right? Because it doesn't know till runtime the correct one to call. Because it's calling over here the squares set length or set width, and it's sending it to, you know, to the same value for both length and width. Okay, so that is that. And okay, here I give you an example. Oh yeah, this is more complicated than it needs to be. Actually, this is way more complicated. I just need to do, I'll just copy this code. Come on. Why isn't it working? Oh, here it is. Sorry. I'll put that in here. Oh, it's over here. Okay. Okay, so this is, and then I'm going to upload the code so you can look at it. Okay. Okay, so we got the L, and then this is very, and then we're up to I. So I is, it's something that it's basically the same as SRP, which basically means is, in other words, okay, do you remember how do we describe an interface? Remember how to describe interface? An interface is like it doesn't have code. It's like a class. It just has the methods but no code, right? So what is it? What is it effectively? Effectively, a interface it's like they use the word contract. I like the word advertise. It's an advertisement of what you could do, right? Like if you see somebody in the airport with a certain uniform, you assume that they're a pilot. If they're different uniform, you assume there might be a stewardess or a steward. So basically, you see someone wearing a policeman's outfit, or you assume that they're a policeman. Same thing with a fireman. So basically, so a interface is an advertisement saying this is what I could do, right? So think of like a person with a certain type of military uniform, or any type of uniform. It's saying that this is what I could do before they even open their mouth. We make certain assumptions because they're advertising this is what I could do, right? If a person has a baker's hat, we assume they're a baker, right? Because they're saying I am a baker. Whether they really are or not, we don't know. But they're advertising they are. So an interface is like, so for example, let's say we have an interface called what my capabilities. Actually, let's keep it like what would be an interface like let's say I I read the math, so uh let's say bake. Okay, I know how to I have a bake interface. Okay, so in my bake interface, I have what do I provide? Well, I know how to. Okay, well, if you get the bake interface, I guarantee that you know how to bake bake a cake. Okay, that's one thing I guarantee. I advertise. And if I know how to bake, I also know how to, I don't know, what else could you bake? Uh, you could, uh, what? Oh, cookies, right. Make cookies. You don't really bake it, do you? Right? You, you deep fry them. To make cookies. And then if I throw in, I also know how to repair ovens. So, so the problem is that what we're advertising is that everybody who walks around saying that they know how to bake, they know how to make a cake, they know how to make cookies, which is good. But we also say they know how to repair an oven, which what does that got to do with the first two, right? It's really a separate skill, right? Yet, but because of let's say I'm lazy and I don't want to make another interface, so I just put everything together in one interface. So, but I'm really combining things that have nothing to do with repairing an oven, which has nothing to do with baking a cake, right? It's a separate skill, right? But yet I'm forcing people who claim that they know how to bake a cake, right? So for example, let's say um, I have um, a baker uh, a baker who claims that they know how to bake. So they implement bake. They're advertising that they know how to bake. Well, because they advertise they know how to bake, I'm forcing them to do all three of these methods. And let's say they only know how to make cookies and bake a cake, but they don't know how to repair an oven. But I'm forcing them to provide that that code, even though they don't, it's nothing to do with their skill set, right? So by adding things that don't belong to an interface, then I'm making this code kind of messy, right? Because I'm forcing this method, because if I would take out repair oven, it would give me an error because it says you don't really know, you don't really implement bake because you don't know how to repair an oven. So so it's better if I just go over here to bake and I get rid of put repair oven somewhere else. Right now, my baker is going to be okay because they don't have to know how to repair an oven. Okay, so that's interface segregation principle means don't force, don't put things that don't belong with all together in one big interface because then you're making the people that use that interface, you're forcing them to do things that they don't really need to do or want to do, but you're forcing them because that's what you put in there. So, so you should limit it to what's really belongs. Okay, that's it for today. And we'll just do D and then we're done with solid. Okay? So we'll continue next Tuesday, right? Okay, right, we have class Tuesday or is it?
Yeah.
It's not Columbus Day, right? Okay, yeah, you're right,
Yeah.
okay. Okay, great, thank you. Good night. Good night, thank you for coming. Oh, you too.
So
Oh, stop share.
it's not